Hey guys, welcome to another video. In this video, we will be looking into what is a good software architecture, why do we need it, and what can be the consequences if we don't follow these good principles. Okay, let me zoom in a little bit so you guys can see it better. So in short, a good software architecture is a way to design a product or application so that efforts to maintain and build the application should be minimum. In other words, if we follow the principles of software architecture, our development effort should be minimized, and with time, the effort should stay the same. So the ideal effort is should be minimized after following our architecture principles. It should not be the case that after a year now you need more and more developers that you already had to maintain the same application. You are not adding any new features, but you just keep adding new developers. So, so this was the effort that you need without following principal architectures. Uh, without following software architecture principles. But this is the effort you need after you follow the software architecture principles. Your effort is minimized. Now you don't need that many developers. You don't need to push that many effort to build the same application. Because if the application needs more and more effort and developers, then you can assume the design was not so good. And we are now just spending more money and time to solve issues that came from bad architecture decisions. These decisions were made initially, but now causing the application in the future because now it is too late to change the design. So I find this interesting article and want to show you guys how many things are to consider to build a good architecture. It starts with clean coding and went up to the enterprise architecture patterns. There are programming, object-oriented design principle patterns that we need to know so that we can apply appropriate ones for our application. And hopefully this course will teach you some. I will give you the link of the article in the description. Also, you guys can check it out. It's a very interesting article. Okay, so what is a bad software architecture? Now, there is always one truth in a software product that the changes are inevitable. And if your application is embracing those changes with minimum effort and difficulty, then you have a good design in place. A change is coming, a change is coming, and change is coming, and you are taking it without much effort. So your application is so flexible that it is easy to fix new pieces into the existing ones. But if your application is having a hard time fitting new places, for example, the puzzle or application in the image is designed to be so inflexible that it cannot accommodate new changes or shapes that are coming. If we if a new feature will come that is out of shape, for example, a circle or kind of rhombus here, that it cannot add it without breaking down the existing structure. And defactoring existing one is costly, especially at the end when you have developed your product. And if you somehow break down middle three pieces, for example, here to accommodate the circle or square, you just fit it there and it worked. But with time, those small fixes or patches will cause more issues or bugs. And one day, your application will just look like random pieces lying here and there. So, what will happen and what is happening on the right is the cost of maintaining the application will go up with time. You you will find yourself in the place where you need more and more developers and more effort to just maintain the same application. So the application should be flexible. One of the principle of software architecture, it should be flexible. Now, how do you know if your team is doing good or not? If you are putting more effort than required? Because it seems everything is going good and we are getting bugs, we are solving it, and it is going well. It happens when you are working. You just assume that it is okay, we get bugs, and that is right, we get bugs. But sometimes behind the scene, things are not going well. Let's see. Uh, let's see how we can analyze it using our existing data from our code repositories. We will use the famous kilo lines of code, basically this one. Sorry. Okay. So basically, 1000 lines of code written is one KLOC. To be honest, I am not a big fan of this to measure how productive someone is based on how many lines of code is adding someone is adding as a developer, because we try to less write the same code in less lines than any inexperienced developer. That does not mean we are less productive. Elegant, efficient, and maintainable software takes more time to write and takes fewer lines of code. But yes, overall, KLOC graph should tell you whether in a product, over time, how much code is getting added. So on the left here, what I think should be an ideal graph, but it can vary from application to application. The initially we write a lot of code, it increases, but with time, when the application, for example, reach a stage where we are maintaining it and not adding a new code, maintaining it. Sorry for the writing. Uh, now the application is complete, and then we don't need many more KLOC to add. That is totally fine. KLOC stays the same. Will only minor features will come. It can be vary, as I mentioned. It can be something like this. For example, sometimes of the year you are adding more code when you are releasing features, and sometimes not. But ideally, it increases a lot initially, but then stays the same after when you reach a maintenance state. Also, it depends on the number of developers, this KLOC. So if you have 5 developers, you are adding a X amount of code, and if you are 10 developers, you are adding Y amount of code. It is natural to assume that y should be greater than x, because more developers should add more number of lines than when they are less. However, there is one it can call it can show us one problem. If your kilo lines of code is not increasing even when you are adding new developers, or it is not increasing at the same rate. For example, from when going from 5 to 10 developers, you do not see much significant increase in the KLOC. You know why it's happening? Because with time, as the design was bad, the developers are only trying to fix the existing bugs or issues in the code, or to refactor the existing code. Let's see this in some graph. You can see on the left, the KLOC started increasing at the start, but after some time, as I mentioned, in the maintenance state, it is kind of stable and not much code is getting added, which is fine. Maybe product has fully developed and not many features are coming. However, if you look on the right side, you will see even though the code is not increasing, the company or team is getting or adding more developers with time. Number of developers are increasing with time. So this right graph is not making sense. It should be clearly the new are added to clearly these new developers that we are adding. Even the KLS is not in. increasing to solve issues that are becoming harder to solve by the existing team size of team. So they need to now add more developers just to keep the application running. This must have costing the company a lot because initially X amount of code was getting added by 5 developers. Now the same amount of code is getting added, for example, by 10 developers. The cost has been doubled, even though the productivity is not. As probably half of developers are only working to stabilize the existing code written. This will not go well on on the long run, right? Because maybe when we are adding a new feature, solving a bug, it is causing a lot of issues in the existing code, and you have to stabilize that first also. So this was one way to look how productive developers are in a team. Uh, I wanted to try this practically to see in real life. Uh, so in the next video, we will use a library to generate graphs, this KLOC graph from our GitHub or a Git repository. Okay, until then, thank you guys. Please subscribe for more upcoming videos.